Okay, so in the lab, all of the solutions that you need are labeled, okay, with like felt pen on the glass, okay, with their chemical formula. All right, so with these here. All right, so there's one jar or one beaker that's bigger than all the others, and it's the one for sodium hydroxide because you use that in 3 different reactions. So we need more of it. Okay, there's also more eyedroppers in it because you'll need it more often. Okay, so there's 4 of the eyedroppers in the sodium hydroxide, and every other one has 2. Okay, so they're all up front. You just need to make sure you're getting what you need. Now, my suggestion for you on how to do this and carry things safely. Okay, you're going to have your watch glass, and you're going to have your reactants in it. But obviously, you don't want to be standing at the front table doing the reaction with the watch glass in your hand. Okay, so here's what I want you to do. Put one of the reactants in the watch glass and take that back to your lab station. Then come back up and get the eyedropper or of the other reactants. Okay, squeeze it, get it nice and full, carry it with the tip up. Okay, so that it doesn't drip on the floor. Okay, then walk back to your table, and then you can get ready to do the reactions. Okay, I still have to grab some thermometers. I forgot to grab them this morning. Right, but obviously you want to have a thermometer in the reaction when it occurs, so you can see if there's any temperature changes during that. If one of your reactants is a solid, right, so that would be pair 2 and pair 7. Okay, they will have a solid reactant. The solid goes in the watch glass. Okay, carry the liquid back in the eyedropper. Right? You don't want to be carrying a scoop full of baking soda back to your lab station. Right, you'll spill it for sure. So put the solid in there and keep the liquid in the eyedropper. In terms of making sure that this can move smoothly and we're not running into each other all the time, when we get over there, I'm going to assign your group a pair to start with. Okay. If everybody does all the pairs in this order, everybody's going to be fighting over the same solutions all the time. Right? The only pairs that need to be done in order are pair 4 and 5. Okay? Because pair 5 uses the end of pair 4 as one of its reactants. So that's the only 2 you have to do in order. Okay? So I'll tell one group you're starting with 7 and going backwards, and another group you're starting with 5 and you're randomizing or whatever. Just we'll make sure that everybody's doing pairs in different orders. Okay? So they're not all fighting over the reactants. When we are in the lab, obviously everyone will need to have their mask on, okay, because we'll be within 6 feet and facing each other. And you need to have your safety goggles on as well, okay, throughout the entire lab. Make sure that they are on.
If we don't finish like the lab this class, do you have
You'll finish.
Okay.
Oh yeah, it's way quicker than the last one. And you guys, I think, learned on the last one how, and we're going to try and do it really efficiently. So you only have to mix 7 things. Like my observations video is 9-minute long. I think it took me 16 or 17 minutes to do all the mixing. It goes fast. You don't have to wait. It's immediate. Everything's immediate. Okay. I think that's it. We did the planning. We did the reaction predicting last Friday, so I think we're good to go across the hall. Okay, so goggles on the entire time, okay, and masks on the entire time. Oh, the waste bucket. That was the other thing. Okay, the waste bucket's in the same place it was the last time. It's in the fume hood, okay, but it's black, okay, not white. It's in the fume hood. When you are done a reaction, take the watch glass, not like this way, okay, over to the fume hood and spray it off with your wash bottle. That's all you're going to need the wash bottle for, is actually for washing this time. Okay, you're just going to spray it off, get the bulk of it to go in the bucket, and then go back to your station and you can wash it with tap water. Okay, that won't make any difference this time. Just get it rinsed and dried before you do your next reaction. Okay? And then when you're all done, okay, rinse and dry and bring it back up to the front. Okay? But nothing should go down the sink. All right, let's just, I'll have you guys follow me, okay, across the hall here. So in your analysis, question number 1, okay, is probably the most important question in the analysis. This is where you need to write out the reactions as they actually happen. For most of those reactions, it's how we predicted them. but there are 2 reactions that did not go as predicted. Okay? You also do not need to write out reactions 4 or 5. We talked about that on Friday. Those are indicator reactions, so you don't need to write them. So what I'm looking for the answer to question number 4. Okay, so what I'm looking for question number 1 is to see reactions written out in their entirety in both formula and word form. So if, this isn't one of your reactions, but if it was, okay, here would be your reactants. I would expect you to predict the products and then balance the reaction. So, all right, I need a 2 here and a 2 here. Okay, I expect to see that for reactions 1, 2, 3, 6, and 7. I also expect to see underneath that the word equation. Okay, so that's the expectation for question number 1. Reaction in formula form, balanced. Word equation underneath. Okay, so don't forget either one of those, because oftentimes I get this handed in and I'm getting one or the other, but not both. Okay, formula and word equations, both. All right, now for some of our reactions, they did not go as predicted. All right, so I'm going to give you a little bit of help with getting the right reactions. I'm not going to give them to you, but I'm going to give you a little help. Okay, pair number 1. What was our observation for pair number 1? Really strong smell. Okay, what did it smell like? Smelling salts or Windex. Okay, what's in Windex? Ammonia. Okay, ammonia is what's in Windex. So if we could smell that, that means that this reaction did not go as we predicted, and a gas was actually formed. That gas, ammonia. You might want to add that right now because that's one of the products. Okay? So it's not a true double replacement reaction. It's a type of replacement reaction, but it's not a true double replacement reaction. But after I show you where that ammonia comes from, you'll be able to do the rest of it because it does act like a double replacement reaction after that. Okay? So where is the most likely place for me to get 1 N and 3 H's from? Yeah, from the NH4. Okay? So if I take the NH4 and I take away the nitrogen and 3 hydrogens, what I'll be left with is that. Agreed? Okay. Can you do a double replacement reaction with those 2 reactants and get the other 2 products? Okay, because that's the reaction that actually happens. Okay, we just predicted it was a straight double replacement reaction on Friday and said that we were going to have ammonium hydroxide and sodium chloride, and we didn't get that. Okay, we're going to get something else instead. So you've now got a double replacement reaction between sodium hydroxide and hydrogen chloride that will produce this stuff plus 2 other products. Okay, whatever the products of NaOH and HCl would be. Right? So imagine that this is now your reaction. This is already in there as one of your products. Okay, so I'm giving that one to you. You just have to predict the other 2. And then, of course, balance the reaction. Okay. Pair number 2 also did not go as predicted. What happened when you mix those 2 things? What usually happens when you mix vinegar and baking soda? It bubbles and fizzes and foams like crazy. Okay, what does that mean is being produced? A gas. Okay, on Friday we predicted this reaction would go like this and we would have sodium acetate and water. Okay, sorry, no, not water. We were going to have, sorry, we were going to have H2CO3. Okay, that's what we predicted. Are either of those a gas? They are definitely not. Okay? What gas was produced? This one. Carbon dioxide gas actually gets produced in this reaction. Okay? It's not a combustion reaction, but carbon dioxide gas gets produced when you mix these 2 things. Where's the most likely place for that CO2 to have come from? From right here. Okay? If I take the carbon away and 2 oxygens away, what I'm really left with is this. An acid-base reaction between sodium hydroxide and acetic acid. Okay, remember also on Friday we said that this is an ionic compound, and if it was truly written the way it's supposed to, it would look like this: hydrogen acting as the metal and acetate as the non-metal. Okay, so now this and this are reacting to produce your other 2 products. Okay, so we need to balance that reaction after you predict those other 2 products. The other 3 that you have to do, pair 3, pair 6, and pair 7, okay, they probably went just as you predicted them. Okay, whatever the rules are for that type of reaction, and pair 3 and pair 6 are both double replacement. Follow the rules. The products you predicted are the products that happen. Same with pair 7. Okay, you had a single replacement reaction between a metal and an acid. Okay, predict the products, and that's what you were going to get. Okay, I did try to show one group. I didn't get a chance to get around to everybody else. Okay, but you did get a gas produced here. Okay, and it was highly combustible. So that was the thing that ends up by itself in that single replacement reaction. Okay. Hydrogen was acting as the metal, but remember that hydrogen, even though it's very metallic, is also a gas, okay, when it's by itself. Okay. So it did become hydrogen gas, which is highly explosive, okay? But luckily in the big environment of our room and in the small amounts that it was produced, okay, I couldn't even hold a flame over it and get much to happen, okay, other than the flame would pop a little bit every time some hydrogen hit it. All right, so for question number 1, we're writing it out in formula form and in word form, okay, proper naming for all the compounds, okay, that's question number 1. Everybody with me so far? Okay, question number 2 is asking about the 2 reactions that produced precipitates. Okay, so 2 of these reactions produced precipitates. It wants to know which of the products is the precipitate. So here's what we have to remember. If something is a precipitate, is it soluble or not? No. Okay, use your solubility chart to check your products. Okay, so whatever your products were, check them. Whichever one was not soluble, that's your precipitate. Okay, so that's all you have to do for question number 2 is say these 2 reactions had precipitates and these are the compounds that were not soluble. So whatever one of the 2, okay, was not soluble, that's your precipitate for that reaction. All right, everybody with me there? All right, so that's what you have to do for the analysis. Those are the only 2 things. Okay, write those reactions out and tell me what the precipitates were. Okay. Remember that for your conclusion, okay, you're copying and pasting your hypothesis, and then based on your data, can you accept or reject it? Okay, I would say, given what we got, that pretty much we should be able to accept our hypothesis. Okay, if it was talking about the signs of a reaction and all the stuff that Dalton says happens in a reaction, we saw all those signs, so okay, it should be, you know, you got to say in there somewhere about how your observations and stuff do confirm that. And then for your sources of error, 2 sources of error and ways to fix them. Okay? And you can probably use one of the ones I gave you from the first lab. Okay, about the common samples. I think you could probably use that one again, as we still used common samples at the front. All right, you don't have to do the class discussion. We'll talk about that after I hand back the labs after I've run. Okay, so save yourself some work. I know a bunch of you actually did them the last time. Save yourself some work. You don't have to do the class discussion. They're for us to discuss in class after I hand them back. Hence the name. All right, you have the rest of class. I would say, well, you got like another 10 minutes before we got to start cleaning. Okay, work with your group and see if you can get those reactions figured out. Okay, tomorrow you will have a quiz on chemical reactions, and then we're going to be working on predicting the products of a chemical reaction. Okay?